Good afternoon. I am SB Warrior, Director Sales from Kalkitech. I take this opportunity to welcome you all for this interesting webinar on automated fault collection, analysis, and fault location for distribution network using Sync 2000. With the increased complexity of grid networks, to ensure faster response in restoration of fault, nowadays it has become very important to transfer the fault data located in the IEDs at the substation in a minimum possible time to a central location where it can be reliably and quickly collated and analyzed to decide on corrective measures to not only to restore the faulted network, but also to prevent future occurring of similar faults. On a thumb rule, previously, 80% of time was spent in collecting and bringing the data, presenting on a common format or time scale, etc., to the protection management experts, who get only the remaining 20% of time to come out with an actionable conclusion. Now, with the advent of automated fault collection, analysis, and fault location systems, the table has turned with the data available in 20% of total time, and the experts now have 80% of their time left to do the analysis and to reach proper conclusions and recommendations. Mrs. Kalki Communication Technologies, Kalkitech, has executed the first of these systems for the extra high voltage level substations of Power Grid Corporation of India Limited, PGCIL, the national utility, transmission utility in India, for their NTAMC project, the National Transmission Asset Management Center. In this project, the fault data from approximately 250 numbers, 400 kV and above substations, from the length and breadth of India is collected at the control center in Manesar, near Delhi, within a few minutes of the occurrence of the fault, and at Yelahanka in Bangalore, which is a mirror of the main control center. With the analysis of the data, power system experts can provide actionable advisories to the substations on setting changes, feeder loadings, etc. Internationally, we have supplied to REN Portugal and IPCO Greece. After the success at the EHV levels, a few other state transmission utilities in India have also gone in for similar systems, like Karnataka and Tamil Nadu, and many others have this in their future plans. Having successfully implemented in the transmission substations, we have developed a similar system having the same superior functionalities, meeting the needs of the vast number of sub-transmission and MV substations present in the distribution and industrial grid networks. EDP in Portugal has already implemented in 150 stations after a successful initial pilot project. Since many of the MV networks are equipped with earlier generation numerical protection without the fault location function, we have optionally included a simple but accurate fault location function also in the substation DR collector DCU, the data concentrator. We are very happy to share the details in the ensuing webinar, where I invite you all to participate. I now invite my colleague, Mr. Fahid, who was extensively involved in solutioning for various utilities across the globe, and in this session will highlight the details of the solution and its benefits for the MV networks with various use cases. In case you have any questions on this, you can select from your control panel, and then you can type in the details, and we'll be very happy to answer you. Thank you. Thank you very much.
Thank you. Yeah, thank you, Varya. So, good evening to all. Today, I'll be dealing with automated fault collection, its analysis, and our solution for calculating fault location for the MV network using Sync 2000 gateways. So going ahead with the agenda items. So what first we are dealing with what are the problems we are solving, followed by system architecture, its component, different use cases, fault record formats, what we collect, simultaneous data access, that is for configuration as well as fault and event retrieval, simultaneous data access. Then loop impedance calculation algorithm, how we calculate the loop impedance from the contraid or fault file, and how we are sending it to calculate accurately the location to fault. Then accuracy of is-er loop calculation based upon our experience with the multiple substation. Then some of the sample cases, how it is calculated in some of the sample cases. Then central IED management and security requirements of IED management. So these are the agenda items we are planning to cover in this session. So moving ahead with the problem statement. So first and foremost thing is utility want to get the locations predicted or location of the fault predicted for the MV grid. And you know it is a radial network, so it is not as simple as in the case of transmission network, and we need to have extensive algorithm to predict where the fault has come. Second case is fault generated by multiple from the multiple relays need to be collected in a and made it available in a common format as a fault file, and need to be provided to the central system for detailed analysis of what has caused the fault. Third point is along with the fault data, the events that has occurred need to be superimposed with the fault data for the analysis purpose. So you can correlate all the events available and the fault data analysis, so that you can directly derive at the root cause from the events, fault data and fault file analysis. Third, next point we are trying to address is configuration need to be separately managed by the vendor tool, and we need not do anything with it. The same scenario need to be continued, but everything need to be provided from center. So central tool need to enable this configuring, launching the corresponding tool, and to have a mechanism centrally to do complete management of multiple IEDs at multiple locations. Then, as the system is highly critical, especially on the IED device management and other stuff, and any parameter setting going wrong in any of the parameter setting, doing it centrally will make the system effects of a catastrophe. So we need to have a high-end security concept involved in doing the stuff. So it involves multiple mechanism like role-based access and other things are there, along with the TLS 1.2 based tunnel and a VPN based setting from the center. So need to have multiple mechanism to tunnel, VPN, then role-based access, multiple things need to be addressed to solve the customer problem. So moving on to the system architecture. So this is very simple system architecture. So there are multiple IEDs in a MV network, MV substation. So that can be in multiple protocol, like 103 is one of the common protocol. 61850, now there are new substation, there are multiple 61850 IEDs, and there will be existing IEDs with vendor relays like Alstom or Arriva will be having their courier protocol supported relays. ABB will be having ABB SPA relays, and there are multiple Modbus implementation, in the network. So There can be multiple relays available in the network. So we need to gather the data, live data, as well as fault file from all these relays, and we use Sync 2000 gateway for that, and send this data. Live data need to be sent to the local SCADA as well as remote SCADA, and all the fault file collected from all these IEDs need to be converted into a common. So this can be vendor dependent format, like SPA will be having Rival format, Courier has got its own format, 103 has got its own format. So this gateway need to convert all this format into a common IEEE standard format, and that is known as a CompTrade format, and this is pushed to the central system for detailed analysis. And apart from the live data collection, fault file collection, this can also collect events from all these relays, the events available in all these relays, and we can convert, make these events into a CSV file and transfer along with the CompTrade data to the central system. So that is also available. And apart from all these things, once the disturbance or fault file is available in Sync 2000, we run an algorithm known as a loop impedance algorithm. In short, we call it as Z loop algorithm to calculate the loop impedance of the from the feeder, what is the loop impedance to the fault, and this data is sent over the existing protocol to the central SCADA system, which is enabled with the GIS system, and each branch in the MV network, they can indicate what is the impedance value of each branch. So from the impedance provided from the gateway Sync 2000, the central system will be able to calculate where this impedance lie with respect to the fault, and that can pinpoint in a map saying that this is a probable area at which this fault has occurred. So that is, so there are four parts associated with it. One is live data collection, second is fault file collection, third is event collection, fourth is converting it into the loop impedance value and transferring it over the protocol to the central system to calculate the things. Then another key thing is to centrally enable the configuration from the center. We have a power system enterprise suite available at the center, using which it can launch the respective IEDs or relay tools and do the configuration from the center to all the IEDs. So we have a server client installation. So at the center there is a server, and there can be power system enterprise suite clients installed at the multiple substation level, and sitting at the client, anybody can configure any of the relay with the credentials, and his roles are mapped to the functionality he is permitted to do. So role-based access, based upon the enabling role-based access, each person logged in will be able to, using the PSCS client, will be able to do the complete configuration of IEDs in a substation. So that is point number 2. Third is end-to-end security. That is from Sync 2000 to the central location. End-to-end security is enabled with a multiple system like TLS 1.2 tunnel and role-based access and certificate exchange mechanism, certificate validity mechanism, and a lot of other security enabling techniques are used to validate these steps. So this is overall architecture of the system. So without doing any change to the existing system, just need to plug a Sync 2000. Remaining things Sync 2000 will be taking care in a MV substation, collecting all these stuffs, and even doing a calculation of loop impedance. So this is architectural components in detail. As I have mentioned, there are this is Sync 2000. there can be multiple protocol drivers collecting the data from multiple relays, and we have all these drivers available, whether it is SPA, courier, Schneider relay, self-fast message protocol, 61850 protocol, 103 protocol, and other drivers like GE custom Modbus and other functionalities, other protocol functionalities are. And these collected disturbance files are in its own proprietary format. We convert it into a Comtrade common format and push this file to the central system over secure FTP, and we can send it to the central system, and at the central system, detailed automatic fault analysis system can do the analysis of the Comtrade files, and events are also collected from the relays. It is made into CSV format and then pushed on to the central system, and the AFAS tool can analyze the Comtrade, combining the events also. And live data, it can be sent over 104 or DNP3, live poems or protection events, everything can be sent on the protocol basis to the local SCADA system as well as to the central SCADA system. And central, you can have a Sync 4000 or your own system available at the center, and you can exchange the data with other control center in any of the protocols available. So that is. And another thing is the PSCS server client. So PSCS server sits on this central system, and there can be multiple clients, and from the client, user can launch the corresponding tool and then do the configuration of any of the relay sitting at the any of the client machine. Plus, in the Sync 2000 itself, Sync 2000 itself, there can be in the Sync 2000 itself, the loop impedance algorithm is available, and using this loop impedance algorithm, we calculate from the Comtrade file, we calculate what is the impedance value to the fault, and depending upon the impedance value, we put it on the file also containing full details, plus this impedance value is available to map to the corresponding protocols like 104 and DNP3, and the same value is sent to the center to do the complete analysis. So these complete loop impedance values are available and pushed to the central system for doing the analysis. And all these files, Comtrade files, loop impedance files, and event files can be pushed to the multiple locations depending upon how you configure. So there can be a main center as well as backup center available in the network, and there can be a local substation, Comtrade viewer or analyzer, and that can be even pushed to the local control center, local machine for the analysis and viewing purpose. Then moving on to use case details. What are the use cases we cover? So first is fault file collection. The gateways or data concentrator retrieve the fault files from all the IEDs using the vendor protocol drivers available in the Sync 2000 itself, and this is retrieved in its own vendor disturbance record or fault file format. After retrieve along with the fault file collection, it also collects the event files from the IEDs protection relays and convert it into a CSV format, and then that event files are also available in Sync 2000. Then data conversion, The ComTrade format, the fault files are converted into common ComTrade format. Events are stored in common CSV format and pushed to the central system for further analysis. And another key case is loop analytic algorithm. That is, this analytic algorithm is performed on the ComTrade file and calculate the respective impedance value with respect to the fault, and this data is sent to the central location for analysis. Then data to the central location can be through its own protocol, as well as the files can be exchanged using a secure FTP protocol to the central system. Then fault location prediction, central SCADA uses a impedance value for each segment of the line, distribution line, and it uses a GIS database to convert a X value, that is the impedance value is provided, and this impedance, Z loop impedance, is calculated from the feeder point, and with respect to the permitted error limit, it is plus or minus with respect to the error limit. It is superimposed on the map, and corresponding location is pointed out with respect to error location, and the central SCADA can actually point out the corresponding area with respect to the fault locations. Then moving on to the disturbance record format. So there is a common format for transient data exchange, which is an IEEE format we commonly call as ComTrade file. It has got a header, configuration, data, and information files. So 4 files can be there. 2 files are mandatory, which is CFG, and DAT files are mandatory. And so this is the common format available for the disturbance. And apart from the common format for the transient exchange, the 61850 devices uses all the 61850 devices uses this ComTrade format for the disturbance record transfer, and 103 has got its own format, so that is specified in the 103 standard. And there are custom format like Rival format from ABB, and all the SPA loan protocols uses ABB format. And compressed courier format is used by Alstom Areva relays, and that is specified in the courier protocol manual. And there are custom Modbus compressed format, which GE is widely using, and we are coming up now with the Procom format support, which is used widely in South American regions. And another key feature which enable all this thing is pass-through channel. So most of the substation will be having a single connectivity point to the relay, that is single port only for the relay, and we need to have protocol data taken from that port itself. We need to have a DR collected from that port itself, plus we need to have that port to be used for parameterizing the relay from the parameterization software. So what we provide is a transparent or pass-through channel to enable simultaneous access of the live data as well as configuration file. So we have internal algorithm in which 2 methods we can use. One is a total control method, that is whenever there is any data from the parameterization tool, we will pass that data only through the main channel. So main channel get blocked, and this data only is transmitted to the corresponding port. That is a complete control method. And another is cycle stealing method, in which master protocol communicates and it sends packet, and in between when there is a data, this data is sent through the same channel over the protocol port, and the reply is sent to the transparent channel too. So one message from the protocol master and reply to that, and another message from the parameterization tool and reply to that. Like that, it is functioning in the cycle stealing method. But most of our customer, most of the utility prefer to have a complete control method, because parameterization happen occasionally. So they are okay to completely stop the main channel and allow the control for the parameterizing channel, blocking the main channel. So this is a configurable attribute, and a user can define either way on the either way, whether to use a complete control methodology or a cycle stealing methodology to be used. Then moving on to Z loop calculation algorithm. So we run this algorithm. This is primarily intended to calculate the location to the fault, and we calculate impedance, loop impedance from the feeder. What is the loop impedance to the fault? That is what we calculate. So for that, we need to analyze the complete fault file we have received, indicating the fault. So the input to this calculation is the comtrade file, and using this on the comtrade file, we run an algorithm in which we can detect fast and slow variation in the voltage just and we can segregate it transient and stable segments, and to come across with the pre-fault load current condition where it is coming, and we can calculate that. That is the first step in the loop impedance calculation. Then it is followed by detailed calculation of the impedance. So that can be triggered by various conditions. It can be current is over the last trigger value, polarized negative current unbalance over last trigger value, polarized zero current unbalance over last trigger value, polarized wattmetric zero directional value over the last trigger value. So these are some of the trigger conditions used to calculate the impedance value, loop impedance value in the algorithm. And once the value is calculated, at various methods are used for the calculation, and we eliminate the outliers and come across a minimum value for the loop impedance. And this value you can map to any other protocol, and this value is sent to as an event, sent to, like if you map it to 104, these values are sent as an event over 104 with the timestamp and other details. And plus this loop impedance, further details are there in the loop impedance file, and this file also get transmitted to the central location using secure FTP, and if they need further analysis, this file can be used to do the analysis. So that is on the loop impedance calculation. And accuracy of loop impedance calculation. So I have taken a case in which, actual substation case in which we are running the loop impedance algorithm. So 5 substation we have taken, and what is the fault that has come? It is an overhead line substation, and what is the fault, number of faults that has come up, and what is the error. So from the loop impedance value predicted, what is the error with respect to the percentage, what is the error, and you can see the error average is within 5%, and it is normally it is prescribed as 10%, and we are able to reach within the 5% accuracy for loop impedance calculations. And this I'm not revealing actual substation name because of the security reason, so you can understand this is actual substation, actual deployment I'm talking about, running over multiple many months, and then we have analyzed based upon the actual fault. So this is one of the sample case. So this is on GE F650 relay. It uses a custom Modbus protocol, which we call it as a GE Modbus, and the trigger time is 2016, and fault file generated, that is a fault file with a CFG, and that file, it is a COMTRADE file. We convert it into COMTRADE file, and is a loop analytic output is indicated. Is a loop value R and X are transmitted over 104, and their SCADA analyzed with the GIS map, and you can indicate the location. So from the feeder, these two are the possible location with respect to the error permitted and everything. They calculate on the location, and these are the probable locations of the fault that is indicated on that. So two location it has indicated based upon the distance from the feeder, outgoing feeder. Two location has been indicated. Then this is analysis of another relay. It is MICOM courier relay, and it is using a courier protocol, and this is same scenarios carried out, and it predicted a single location where the fault can occur. And this is based upon RUF 541 ABB SPA relay, and it also predicts a single location to the fault indicated on the map. So this is some of the sample case where we have actually deployed this scenario, deployed this algorithm, and come across with the result for the MV distribution utility. Then moving on to, so after loop impedance, then our another major aim is centralized IED management, managing the IEDs or relays from the center. So we come across live data transfer, the fault file transfer, then loop impedance calculation, event calculation, then next step is centralized IED management, device management from the central location. So for that we use a Calcutech built tool, which we call it as a power system enterprise suite. And using this tool has got a database associated with it. So all the disturbance record file or configuration file retrieved are stored in the database itself, and this provides you the history of the configuration file, and you can retrieve at any point of time a previous configuration file or archive and or configuration file to the system. And centralized, and this is a central installable software, so it can have a server installed at the center, and it can have multiple clients, and each client will be, and in the server you can map this to electrical hierarchy like a region, region, substation, and under substation feeder, and under feeder this is the IED, and you can link a tool to the IED, and once you click on that corresponding feeder, that corresponding tool will be getting launched with the latest configuration file, and you can retrieve any previous version configuration file and do the management stuff. So that is the basic principle. So centralized configuration management is available for managing multiple substation IEDs, multiple versions of the configuration tool. Yeah. So in major headache for the utilities, how to manage multiple versions of the tool. So if you come across installation in the substation, there can be multiple versions of the same vendor relay, and multiple versions of the tool need to be used to specifically configure specific relays. So there need to be, and this is not installable on the single machine itself, so multiple scenario need to be used. So this all the congestion, all the things need to be avoided. So this PSCS support multiple versions of the tool, and it can launch specific version from the specific location. Then it has got a database for storing latest configuration file, and that can be automatically uploaded from the relays as well. It supports version management. Then It has got a basic DR contraid viewing functionality and a detail. If you need a detailed analysis, the corresponding tool can be linked to the DR analyzer, and the corresponding tool can be linked to the PSCS, and then when you open the corresponding contraid file, it can be opened in the corresponding tool, and automatically there can be analysis and reports generated. So this is some of the key features of the tool. So tool-based configuration management, you can use the remote access. So centrally sitting at the center or any client machine, PSCS client, you can configure. Then you have a complete hierarchical representation of the electrical system and user customizable view, and it has called a thick client as well as thin client. So web-based configuration is there. Also a thick client desktop-based configuration is there. Then user management is there. So you can create user groups based upon the roles permitted, and you can map the users to the user groups based upon the role. So role-based access based on the functionality or specific regions can be mapped based upon the role, and it can have a Windows or web clients, but it only support Linux for the server. Then it has got a GIS integrated Google map, so all the live substation, all the communicating substation can be indicated over the Google map, and click on the map corresponding map window, and then from there this can be further analysis, further download, everything is possible. Then detailed network management is available, and this information is available through the simple network management protocol SNMP. Audit trail is available to track details of the user activities. Multiple security levels are available. Then configuration alarm categories in the web interface. Then disturbance record or fault file download option from web interfaces are available. So centralized IED management using PSCS is one of the key feature we offer with this package. So this is a quick view of the configuration tool, that is a PSCS tool. This is the thick client, that is desktop installable application. You can see multiple, it is separated into multiple regions like north, east, south, west. So this is basically taken in an Indian scenario, and there can be multiple substation and multiple feeder. Under each feeder there can be multiple IEDs, and each IED you are getting connected to the sync 2000, and you can indicate the live communicating status of the IED is indicated here, and non communicating status. So substation is a indication of sync 2000 itself, and feeders are communicating IEDs are indicated here. And if you launch the tool, the corresponding, for example, now it is cell 421 is selected, and if you launch the tool, the cell accelerator tool will be launched, and further configuration can be done from the tool. Then there can be the files, retrieved file can be archived or retrieved from the database. So all these things are permitted from the IED centralized configuration management system. Then central automatic fault analysis. So as I have mentioned, the PSCS tool provides very minimal level of contraid viewing and other functionality, and there are third-party tools that enable further analysis, like we are using MyFAS tool from PRDC for most of the all the Indian scenario or Asian scenario projects, and we are using other tool based upon the utility recommendation for the for Europe and South American scenarios. So some of the key features they were looking for is automatic generation of the fault summary, and that need to be intimated to the corresponding person automatically over the mail, and over the mail as reports. Then centralized analysis package need to be there, need to do complete central analysis. Provision of incorporating the events also for the analysis purpose. Then protection relay operation, its sequence, time, pickup need to be analyzed. Device operation anomaly need to be analyzed, like operating time mismatches and other things need to be analyzed. Correct operation of protection scheme like auto reclosure, carrier aided, all those stuff need to be analyzed. Then its key aim is reduce the manual intervention of analysis. The analysis should be automatic and need to be provided to the corresponding person who was registered to get that report. Then store the centralized fault analysis report and other details need to be centralized stored and need to be retrieved at any point of time based upon the incident report. So each analysis will be treated as each fault will be treated as an incident, and they can do a detailed analysis, put on the corresponding incident, and user can retrieve the incident, the details of the incident report based upon the incident number or approximate time at which the incident has occurred. Then this need to be all the standardized report format need to be supported. So these are some of the requirement of automatic fault analysis package. Then moving on to security requirement. So this is very much key in the system, because if some abnormal setting is enabled in the IED or protection relay, there can be problems with the complete network. So all the things need to be, we recommend it to be SIP 501, SIP 5.0, that is critical infrastructure protection scheme. This is a standard put forward in US, but other areas also is adopting this standard based upon the security levels at multiple levels, involving personal security, device security, electronic security. A lot of parameters are there in the SIP 5.0, and there is a standard taken from SIP 5.0, and they derive it based upon the intelligent electronic devices. What are the adaptation needed based upon the SIP? What is, and IEEE come across a standard which is known as IEEE 1686, and the corresponding standard details about the requirements based upon the intelligent electronic device scenario. So we comply both of these, and it need to be met by in utility premises. Another key case is user management. As I have mentioned earlier, it need to be specific that this user can only do this is function, and this user can only do this is feeder or this region or this substation. So that level of setting is needed in the user management. So role-based access is very key for all the stuff. Then end-to-end, earlier we were going for end-to-end VPN in earlier scenario, but now they are changing it to a TLS based tunnel, and we support it TLS 1.2 based tunnel between substation to control center. Another key case is 62351 based security standard. This is a detailed standard that has come up with the security in principle at various levels, like a protocol encryption security is there, then protocol ways control, that is one person who can only do commands, one person can view and command it, and then there is 62351 adaptation for all the protocol like DNP3 secure authentication they have adopted, plus 104 adaptation, and a lot of other things are there. There are standard for certificate exchange, that is symbol certificate exchange protocol. Then there are validity check protocols are there. Then there are cipher suite and other hash algorithm protocols are there, which are based upon 62351 scenarios in the for managing the complete security. So these are key highlight of security. which are needed when you manage any IED from the central location. So these security concepts are valid with. So with this, I'm coming to end of the session, and we are moving on to the questions session. So I'll go through each and every questions and then answer one by one. And if you have further question, please feel free to point out those questions. So one of the questions that has come up is PSCS and Sync 4000 are the same? That is one of the questions that has come up. So the architecture here is, this is architecture. So in this, we can have Sync 4000 is basically a protocol enabler in the Sync 4000. So this Sync 4000 can have protocol masters and slaves in Sync 4000. Plus, it can have a plugin as a PSCS server functionality can be associated with the Sync 4000 plugin. So single server, you can install Sync 4000 based protocol drivers as well as the PSCS server things in a single entity itself, and most of the installation follow that method. So PSCS is nothing but a facility for managing the IED tool is what PSCS drives, and Sync 4000 is much more focused on the protocol drivers scenario and its management, but it is interdependent, and you can have both. If you want protocol drivers and other live data to be exchanged, you can have both PSCS as well as Sync 4000 in the same system itself. Another question is on Z-loop implementation. What is the utility return of investment for Z-loop impedance? So we have a detailed analysis based upon one of our deployment in EDP Portugal, that is the distribution side of the Portugal. So based upon their analysis, so they have a feeder protection relays in all the MV substation, and additional thing they needed was just a Sync 2000 collecting the data, that is disturbance record file, calculating this loop impedance and providing this data to the central system, and in the central system doing the detailed analysis at the central system. So based upon their analysis, a third fault occurred in the substation. That is, just a third fault occurred in the substation completely recovers the cost for their installation. So that is the ROI calculation they have come across based upon the 150 installations in the EDP, multiple EDP substation. So how they gone is, first they have implemented in 5 substations as pilot. They tested the complete use case scenario, and once they are satisfied, they have worked out with the further deployment, and it is deployed in 150 substation across 150 substations. And another question is whether you support a Dixie protocol. Okay. So thing is that there is a difference between 103 protocol and a Dixie protocol. So 103 is basically a general standard IEC standard, but Dixie is Siemens customization on IEC 103. So there are additional messages over 103 for Dixie communication port. But the thing is that presently we are not supporting Dixie, but we support 103, and we are discussing with one of the utility in UK, and there is a requirement for Dixie protocol also. So if that project, we get that project, we will be working out for the Dixie protocol as well. So that is answer on the Dixie protocol. Then another question is, event file, any specific format you use for the event file? Do you support a ConfDA format? So presently, as per the requirement, we analyze the ConfDA format, and it seems to be an overkill to support ConfDA format, that is event collection format similar to ComTrade. For event representation, there is a ConfDA format. But the problem is the analysis tool, none of that is presently supporting. Very few only support ConfDA. So people prefer to have a CSV format for event collection. So we do the conversion of events into a CSV format and use that for logging the event files. So that is the answer. So ConfDA we are presently not supporting, but any tender or anything demanding ConfDA, we can come across that standard. Then another question is, how do you map the events? Is it automatic? So the question is about like in protocol, there can be multiple format in which events are coming, like bits are there, and in SPA format, it can be a 10, that is channel number, followed by E, then the event number is there. So do you have a automatic mechanism to convert it into a standard description, and then what is a value format? So 61850, we have an automatic mechanism for event thing. So since it is a tag oriented protocol, 61850 from the tag itself, we could analyze this is the event. We can put the tag and the event details in the 61850. So we can readily retrieve the events from 61850. Using the report control block or any other things, we can retrieve the events directly and directly convert it into suitable, automatically convert it into suitable format, and then push that to the central system. And we can have, this is based upon the substation level, this file will be available on the event file will be available, and this is pushed to the central system based upon the events which we collect. But other protocol like SPA, Courier, everything is coming from the relay in a total different format. So what we need to do is, user need to sit and map the event number to actual description and what is the change, and once that need to be done, to enable that to a automatic description scenario to be exposed to the center. So whenever we propose this, people prefer in new things 61850, let's get it automatically, but other mapping is bit tedious, because every event need to be for every event there need to be a description, and what are the value and other descriptions also need to be provided. So what answer is, for the automatic collection we only have in 61850. Other protocol, though we collect, the mapping is needed to make it user understandable format in other protocol. Okay, and another question is, from the ComTrade file, do you also collect the events and expose it? The question is, what I was mentioning is the event from the IEDs directly, but this question is on whether from the obtained ComTrade file, can we extract the events? Because there are digital channel associated with the ComTrade file, whether we can extract the events from the digital channel of the ComTrade file and expose it as an event file. So this scenario we do it in PSCS tool, which is available at the center, so that whenever it receives a ComTrade file, it analyzes the digital channel and takes that event, and that can be seen in the event list. And this we are also working in one of the tender to convert it into CSV and push to the central analysis system. So analysis system will be having ComTrade file, plus this event extracted from the ComTrade file plus live event from the IEDs also. So this thing, so answer is yes, we extract the event from the ComTrade file and we make it available in the event list, and we are working on making it available in the CSV format from the ComTrade as well. Okay, another question is it possible to collect disturbance file from 103 slave using 103 master in the protocol gateway? Yes, that is what we do. Like if you see this architecture, here you can see 103 relay. This is nothing but 103 slave protocol, and in this we will be having 103 master protocol, and we collect the live data as well as the ComTrade file from this 103 relays in 103 format. We convert it into general ComTrade format and push to the central system in the ComTrade format itself. So all these protocols are supported in its own format. Plus now we are working out if there are multiple systems that is already collected the thing and they have it in ComTrade, we can collect it using a secure FTP client server available here, and we can directly collect in from the PC and other stuff, the ComTrade files only, and we can collect it here, and that can be made available to the respective channels. So that is one. And another question is, do we get a PPT of this webinar after the same? Yes, we can provide that. We will make the same available to you for further. And you can also, you have my mail IDs here in the last slide. So I will share that. You can put questions to me if you have any further clarification needed. You can ask questions to me directly, and I will be. It will be a pleasure to answer your question. So this is and one more question that has come up is automatic collection of configuration file. One more question that has come up is on automatic collection of the configuration file. Yes, we do support. For a project now we are evaluating automatic collection of the configuration file based upon the scripting, and need to collect from configuration file. This is on the configuration file, and we are planning to for the project, it is the requirement is collect from the IEDs, then compare it with the master configuration file that is available, and whenever there is a change detected from the available configuration file, we need to throw an alarm. So that we are now working out. We are successful in implementing it for cell relays, and we are working out for other relays also. So automatic configuration file retrieval and exposing it over making it automatically available to the databases of PSCs. So I have answered all the questions that has come. If you have any question, please feel free to mail me.